Now let us move to the next question, that is question number 13. Question number 13, in Young's double slit experiment. As you heard the name Young's double slit experiment, you can easily recall that this is from wave optics again. In Young's double slit experiment, the separation D between the two slits is 2 millimeter. Between the two slits means it's like this. This is the two slits S1 and S2, and the distance between them initially is given to be how much? 2 millimeter. Fine. The wavelength lambda of the light used is 5896 Armstrong, and the distance D between the source, between the slits and the screen is 100 centimeter. If I keep a screen here, that distance D is given to be 100 centimeter. Okay. It is found that the angular width of the fringe is 0.20 degree, full stop. To increase the fringe angular width to 0.21 with same wavelength and D, the separation between the slits needed to be. Okay. Here the angular width is given. As we know from the formula, angular width is given by, see, theta is equals to lambda by D. At first theta is 0.20 degree and lambda is given to us how much? It is 5896. 5896 into 10 to the power minus 10, that is in Armstrong, right, divided by the distance D. Distance D is given as 2 millimeter. So 2 into 10 to the power minus 3. So put it equation number 1, theta 1. Now again, how much will be the D if angle is now changed for the same lambda, and you have to find out D. Theta 2 is now 0.21, right? Now lambda is same and D is we need to find out. Put it equation number 2. Now what you will do? Just 1 divided by 2. If you do this, you will see that your option is coming out to be, or the answer is coming out to be 1.9 millimeter. Please try to solve it by yourself. I have given you the application. The answer need to be taken by you. So 1.9 millimeter is the correct answer, option 3. Now let us move to the next question, that is question number 14. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has objective lens of. As we know, if you want to focus anything, the objective lens focal length has to be large and its radius also has to be more, or its diameter. So question option number 1, small focal length, no. Large focal length and large diameter, true. Number 3, large focal length and small diameter, no. Number 4, small focal length and small diameter, no. So your answer will be option number 2. This is from the chapter Ray Optics. Study the topic astronomical telescope. There only you will find that. Now let us move to the next question, which is question number 15. Question number 15 says that an electron of mass m with an initial velocity v equals to v naught I, where v naught is greater than 0, enters an electric field E equals to minus E naught I, E naught equals to constant which is greater than 0 at t equals to 0. If lambda naught is its de Broglie wavelength initially, then its de Broglie wavelength after time t is, you need to find out this value. Okay. So there is a concept of de Broglie's wavelength and electric field. So it is the combination of two chapter, I will say, that is dual nature of radiation and matter and the electric charges and fields of class 12. Now how do you do this one? As we know, de Broglie's wavelength initially is given by lambda is equals to h by m v naught. This is the initial velocity. Okay. Now in the second case, electric field has come into the concept, right? We know force is equal to mass multiplied with acceleration. When there is an electric field, force is equals to QE. If I combine both of them, MA will be equals to QE. Therefore, A will be equals to QE by M. So you have the acceleration. Why I need to find out the acceleration? Now, so that I can put it in the equation, V will be equals to V naught plus AT, equation of motion. So V naught plus A is how much? QE by M multiplied with T. Now if this is lambda 1 initially, my lambda 2 will be equals to H M V naught. In place of V naught, you will write down V naught plus QE by M multiplied with T. So how will you do it? H by M, if I take V naught common out here, it will be 1 plus QE divided by M V naught multiplied with T. So H by M V naught is my initial wavelength, that is lambda 1. So lambda 2 is equals to lambda 1 plus QE divided by M V naught multiplied with T. So let us see which one is the correct answer from the option. Now if you see the option, the correct answer will be option number, which one? Option number 1, that is lambda divided by 1 plus QE, that is Q is E out here, M V naught multiplied with T. So I will click on number 1 is the right answer. Now let us move to the next question, that is question number 16. Number 16. For a radioactive material, half-life is 10 minutes. When I talk about half-life, means it is coming from the chapter nuclei of class 12. If initially there are 600 number of nuclei, that is N naught is your 600, the time taken for the disintegration of 450 nuclei is, now you have to find out the total time. So how do you solve it, my dear? N by N naught is equals to half to the power N. Now N is the number of atoms present. Like how many atoms will be present? 600 minus 450 will be equals to 150. So 150 divided by N naught is 600, which is equals to half to the power, in place of N I can write down, we know total time T is equals to T half multiplied with N. So N will be T divided by T half, right? So it will be T divided by T of half. So what you will get? If I cancel this one, it will be 1 by 4, right? It will be half to the power T divided by T 1 by T half, that is half-life. So 1 by 4 can be written as 1 by 2 whole square. On the right hand side also we have 1 by 2 T divided by T half. Half is in the suffix, just telling you that it's a half-life. Now both the same, so this will be equated. So 2 will be equal to T multiplied with T half. Now total time T is equals to 2 multiplied with T half, and T half is given in the question is how much? 10 minutes, right? So 2 into 10, answer is 20 minutes. So if you go in the option, your right answer will be 20 minutes, which is this. Now let us move to the next question, that is question number 17. Question number 17, it says that the ratio of kinetic energy to the total energy of an electron in a Bohr orbit of hydrogen atom is. This is from the chapter atoms, where you can write down as, we know that total energy is equal to minus of kinetic energy. So you have to take the ratio between total energy and what? Kinetic energy. So total energy minus of kinetic energy will be equal to 1 is to minus 1. So which one is the correct answer? Option 3 is the correct answer. So now we will move to the next question, that is question number 18. Question number 18 says, when a light of frequency 2 mu naught, okay, where mu naught is the threshold frequency, is incident on a metal plate, the maximum velocity of the emitted electron is v1. What is the frequency of the incident radiation when the frequency of the incident radiation is increased to 5 v naught? The maximum velocity of the electron emitted from the same plate is v2. Now what is the ratio of v1 to v2? Okay, now this is a question from dual nature of radiation and matter, where you have to use Einstein photoelectric equation. Now I have to show you this one. Let me go. We know Einstein photoelectric equation is given by E is equals to, what do you write down? H mu naught plus kinetic energy, that is half m v square. For the first case, E equals to h mu we write down, but out here the mu is given to be how much? For the first case, mu is twice mu naught, so it will be 2 mu naught, 2 mu naught, which is equals to h mu naught plus half m v1 square. So finally it will be 2 h mu naught. So if I bring this h mu naught on the other side, h mu naught will be equals to half m v1 square. Put it equation number 1. Now see the second case, where in place of 2 mu naught I am going to put 5 mu naught. h5 mu naught is equals to h mu naught plus half m v2 square, right? The velocity is now v2. So here you will get 4 h mu naught. If I bring this one in the other side, half m v2 square, right? Put it equation number 2. Now you have to calculate the ratio of v1 and v2. Now divide 1 by 2. 1 divided by 2. What you will get? On the left hand side you have h mu naught divided by 4h mu naught, which will be equal to half m v1 square divided by half m v2 square. Half m get cancel out, h mu naught get cancel out. v1 square by v2 square will be equals to 1 by 4. If I take square on the other side, v1 by v2 will be your 1 by 2. So the answer is 1 by 2, that is 1:2. Now look at into the option. Remember, 1:2 is the answer. So your answer is number 1, that is 1:2. So I can click on it. Now we'll move to the next question, that is question number 19. Question number 19, an object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. Now in the second case it is saying that if the object is displaced through a distance of 20 cm towards the mirror having same focal length, the displacement of the image will be, means the change in displacement of the image. Okay, now you have to calculate v1 and v2. Again, this is a question from ray optics, where you will be using the formula 1 by v plus 1 by u is equal to 1 by f. In the first case, you need to find out v1, that is 1 by v1 will be minus, object distance is always in minus. How much is the object distance given to you? 40. Which mirror you are using? You are using concave mirror. The focal length will also be minus, so 1 by minus 15. So from here you calculate v1, right? And then you calculate v2 using the same formula. In place of, if this is equation number 1, you will put in equation 2 again 1 by v2 plus 1 by u is equals to 1 by f. The focal length of the mirror will remain same, right? So 1 by v2 minus 1 by u is given to be how much? 20 out here. So which is equals to 1 by 15. From here you will calculate v2. Fine. So put it equation number 2. So from 1 and 2, what you will do, you will just take 2 minus 1. Then you will see that your answer is coming out to be 36 centimeter, which will be away from the mirror. So your final answer is, the solving part you do it by yourself, 36 centimeter away from the mirror, option number 3. So now let us move to the next question, that is question number 20. The refractive index of the material of a prism is 2 and the angle of prism is 30 degree. Okay, in the exam actually this question out here is 2 given, but it has to be root 2. It will be root 2, please keep it in mind. And the angle of prism is 30 degree. One of the two refracting surface of the prism is made of mirror invert by silver coating. A beam of light or beam of monochromatic light is entering the prism from the other face will retrace its path after refraction from the silvered surface. It is if its angle of incidence on the prism is. Now you need to calculate the angle of incidence of the prism. Okay, how you are going to do that? So now how do you solve this one? Suppose this is my prism. One side is silvered, right? And the angle of the prism is given to be how much? 30 degree. A ray of light incident here. So its normal will be perpendicular to the surface. Fine. Okay. Now where the refracted ray will go? It will bend towards the normal. This is the refracted ray. If this is 30 degree, according to the geometry, this one will also be 30 degree. And how much will be this angle? Because this is 90 degree, so this portion will be how much? 60 degree. This normal n is 90 degree to this plane. This is 30, so this one will be 60. So your angle of refraction is coming out to be 30 degree. Fine. So let us calculate now. We know sin I by sin R is equal to refractive index. So sin I by sin R is how much? Sin 30 degree. Refractive index is root 2, as I told you. So sin of I will be equal to sin 30 degree multiplied with root 2. Sin 30 degree is 1 by 2 into root 2. So 1 by 2, 2 can be written as root 2 into root 2. Your final answer will be 1 by root 2. So sin of I is equals to 1 by root 2. So I will be equals to how much? Sin 45 degree is 1 by root 2. So your correct option for this angle of incidence will be 45 degree. So let us see in the question, do you have this option or not? Remember, this is root 2. I can solve it with 2 also, but with 2 the options will not come out. Okay, angle has to be 90 degree if it is 2. Okay, so your option is this one, 45 degree.